Hey everyone, and welcome back! If you're an engineer, an architect, or even a curious student trying to wrap your head around structural design, you've probably encountered one-way slabs. They're everywhere, from parking garages to office buildings. But understanding why they work and how to design them correctly can be tricky. In this video, we're breaking down the one-way slab in plain English. We'll cover what it is, how to identify it, the key design principles. All right, let's start with the basics. What makes a slab one way? It's all about how the load, that's the weight of everything on top, gets transferred to the supporting beams or walls. For a one-way slab, the load is carried predominantly along its shorter span. Think of it like a plank of wood supported at both ends. If you stand in the middle, it bends along its length, right? The same principle applies here. This happens when the ratio of the slab's longer side to its shorter side is 2 or more. So, if your slab's length is at least double its width, you're likely dealing with a one-way slab. We'll get into how to confirm this in a sec, but that's the fundamental idea. The load has a clear preferred path downwards. Now, how do you know for sure? The golden rule, as I just mentioned, is the aspect ratio. Take the length of the slab, the longer dimension, and divide it by the width, the shorter. If that number is 2 or greater, it's designed as a one-way slab. Simple enough, right? But here's the catch. This rule applies to clear spans, not the overall dimensions. You need to subtract the supporting element's widths where the slab rests. Always measure the distance between the faces of the supporting beams or walls. Get this wrong, and your entire structural calculation is off. We'll talk about the consequences of that later. So, we know the load goes one way. How does the slab actually do that? It acts like a series of parallel beams. The main reinforcement steel, the bars that provide the muscle, is placed running parallel to the shorter span. These bars are designed to resist the bending moments created by the load traveling across the shorter distance. Then, you have secondary or distribution reinforcement. This steel runs perpendicular to the main bars, parallel to the longer span. Its job isn't to take the primary bending load, but to help distribute the load evenly to the main bars and control cracking. Think of it like this. The main bars are the big joists, and the distribution steel is like smaller cross bracing. Both are essential for a strong, stable slab. Now, this distribution steel is important, but it's often designed with less area than the main steel. Why? Because it's not carrying the primary bending. Missing this can lead to underdesign, which is not just expensive to fix, but incredibly dangerous. Don't let this be you. Understanding one-way slabs is fundamental, and hopefully this guide has made it crystal clear. If it has, give this video a thumbs up and subscribe. It really helps the channel reach more people like you. And I want to hear from you. What's the most confusing part of slab design for you? Drop your biggest challenge or question in the comments below. I read them all. Comment below, your biggest slab design challenge? Thanks so much for watching. If you want to dive deeper into structural engineering, check out my video on two-way slabs explained next, right here. Keep building smart, and I'll see you in the next one.